in this next section, we're going to be talking about how we can multiply radical expressions together. So if we're going to look at examples 9 and 10 together, and then I'm going to ask for you to do examples 11 and 12. So if we look at example 9, we're taking a binomial radical expression, meaning two terms, multiplied by another binomial. Just like if the radicals were variables, what we're going to do is we're going to FOIL, first, outer, inners, and last. So if we multiply our first two terms together, 5 times 3 gives us 15. We move to our outers. Now, when we are multiplying, we can only multiply integers with integers, radicals with radicals. So in this example, we're taking an integer of 5 multiplied by a radical of 5. So in this situation, we can't really multiply them together. So what we just do is we write them as the product. So that's just going to become the negative 5 square root of 5. We now move to our inner terms. Same thing. We're taking the square root of 7 times 3. They're not like terms, so we just write them as the product, which would be 3 square root of 7. And then we multiply our last. Square root of 7 times the square root of 5, they're both radicals. Therefore, we can write them as the square root of 35. Now, at this point, what we would look to do is we would look to see if we can simplify. If we look at what we have here, this looks very similar to what we were dealing with in the last section with adding and subtracting. So first thing we want to do is we want to look to see if we have any like radicals, which in this example we don't. But what we also want to ask ourselves is whether if any of the radicals can simplify. So 15 doesn't have a radical, so that can't simplify. The second term has the square root of 5. Square root of 5 can't simplify. Square root of 7 can't simplify. And the square root of 35 only has factors of 1 in itself and 7 times 5. No pairs. So this is kind of one of those situations where once we FOIL, we can't combine any like terms, nothing simplifies, but we can leave that as our final answer. Always just make sure you're looking to make sure that your radicals are completely simplified and all like radicals are combined. If we look at example 10 now, we're taking 5 plus the square root of 7 multiplied by 5 minus the square root of 7. If you look at both of these binomials, you're probably going to notice something very unique about them, which is that they're the same exact terms, but they're the opposite signs. This is what we're later going to call conjugate. So make a little note of this on your notes. And whenever you multiply conjugate statements together, what's always going to happen is it's A, middle terms are going to cancel, and B, it's always going to simplify to an integer. And this will be beneficial later on. So if we start the process, first terms, 5 times 5 gives us 25. We move to our outer terms, 5 times negative square root of 7. Since we can't multiply them together, we just write it as negative 5 square root of 7. We multiply our inner terms, 5 square root of 7. And then our last terms are going to give us negative square root of 49. Now at this point, when we go to combine like terms, first thing we're going to look at is our middle terms. They are the same, but they're also the opposite. So negative 5 plus 5, they actually end up canceling each other out. If we also look at our last term here, square root of 49, that's actually a perfect square. If you were to take the time to break it down like we do in the last examples, you're going to see that it's just going to leave you with negative 7. So we have 25 minus 7, leaving you with an integer of 18, validating what we talked about before. So same terms, opposite sign, conjugates, and conjugates will always simplify to an integer. So at this point, stop the video and then complete examples 11 and 12.